Okay, this is Tuesday's lecture. No, this is Wednesday's lecture. Wednesday's lecture. On our inverse trig functions. And I want to start by just imagining you saw this, that you had a cosine inverse and it said minus 3/7. What do you make of that? Now this is a non-calculator problem. I don't want to come up with an exact answer. I just want to think about what this is. Okay, the first thing that we know is that this cosine inverse can be thought of as an arc cosine of negative 3/7. So what do we make of that? Well, this is an arc whose cosine is negative 3/7. Let me name this arc. We can name it whatever we want. I'm going to call it theta because I like to see arcs and angles as theta. And then let me just think about a unit circle problem. So it says the cosine is negative. Cosine is x coordinates, so that's going over here this way, and it's negative 3/7, which is about there. So I have this point, and there is a angle or an arc theta. And the only thing I really know about this ordered pair is the x-coordinate is negative 3/7. I really don't know much about the y-coordinate. I do know, however, interesting. I do know that x squared plus y squared is 1, or cosine squared plus sine squared is 1, right? That's our basic Pythagorean identity. And I do know that the cosine is negative 3/7. Negative 3/7 squared plus sine squared is 1. So sine squared is 1 sine squared theta. It's 1 minus, what's that, 9/49? So 49 minus 9 sine squared of theta is 40/49. So the sine of theta could be the square root of 40/7. Technically plus or minus, because remember there was another point down here where the x-coordinate was minus 3/7 and the y-coordinate would be the minus root 40/7. Up here in the blue, this would have been positive root 40. So minus 3/7. Root 40 is just screaming out to be what, 2√10/9. Sorry, over 7. Over 2√10/7. Okay, so there's theta. And there is this other angle down here. Maybe we should call it something else. Wow, it's exactly the same amount, but in the opposite direction, minus theta. But we are dealing with this cosine inverse problem. And if you recall how we generated this inverse function, we looked at the cosine wave, right? So the cosine wave, something like this, and we noted immediately that it was not invertible unless we made it 1-to-1. So we only looked at this portion of the wave, right, that portion, and we noted that, let's see, this would have been pi to here, so that when we generated the graph of the inverse cosine, we had this. Somebody asked me this morning, well, we have to know how to graph the inverse cosine, and the answer is no. But it goes up to pi, this being 1 and negative 1. But the point I'm trying to make here is that this arc, this inverse cosine, this arc cosine, has to be some number between 0 and pi. So if I'm calling it theta, I have to be on the top of the circle here. I have to be between 0 and pi. This red one down here is bogus. I don't really care about that. Okay, so I do know that the angle theta will be in the top of the circle here, okay? So this angle theta is ending up in quadrant 2. Okay. I could do similar types of problems if I said the sine inverse of, I don't know, 0.332. And so this is an arc that has a sine of 0.332. And I know the arc sine is defined only between negative pi over 2 and pi over 2. You can go back and look at your notes about the way the sine wave was restricted. And because this sine is positive, I'm sitting about here. So again, maybe I can think about this arc as being something. This time I'll call it beta. Beta is an arc or an angle that has a sine of 0.332. So here's beta right here. And I don't know the ordered pair. I do know the y-coordinate is 0.332, don't know the x-coordinate. I suppose I can find it using sine squared plus cosine squared is 1, but I don't want to do that. But I do know if I see this arc, whatever I call it, beta or theta or something else, is in quadrant 1. Go back over here. Cosine, arc cosine, it's either going to be in quadrant 1 or 2 every time. For arc sine, we're either going to be in quadrant 1 or quadrant 4, right? Could be down here if the number was negative. So if I said, talk to me about arc sine of -3/4, I know the angle has to be down here somewhere in quadrant 4. Arctan, likewise, arctan, let's say, of 8/3. This is some arc or some angle. Let me call this one mu. Mu is an arc or an angle, and the arctan is only defined on the right side of the circle. We never actually get to the top or bottom, right? So this arc, this mu, is always going to fall between pi over 2 and negative pi over 2 every time, right? And this particular one, it says it's positive. We're probably somewhere up around here. This might be mu. Yeah. Okay. Whenever you see an inverse trig function, think arc or angle. Now, we can combine these with certain combinations. Here's a problem that was not in the homework, but it's similar to those, and in fact, it may be coming up tonight. What is the cosine of the arc sine of 3/7? Okay, so what does that equal? Now, again, I'm going to think this bit is an arc or an angle. I'm going to call it theta. And I can go back to my unit circle if I want. And I'm in the first quadrant. We're positive. So I can think this is 1. This is a right angle. The x-coordinate, I don't know. But I do know the y-coordinate is 3/7, right? Because it says the sine of this angle is 3/7. The ordered pair has 3/7 here, and then I believe this one was what? It was 2 square roots of 10 over 7, right? If we did the sine squared plus cosine squared is 1. But there's actually an easier way of doing this. So I don't think the book shows you this, but I think it's useful. Let's just consider our right triangle. So now this is going to be not on the unit circle. It's just a right triangle. We still have this angle theta. Right, theta. But now I know that the sine of theta is 3/7. That's what this says. This says we have an arc whose sine is 3/7. Instead of using arc, I'm going to think angle. This is an angle whose sine is 3/7. Okay, I have a right triangle. There's my angle. And let's think about how sines were defined in geometry. The sine of an angle was the opposite side divided by the hypotenuse, right? So the opposite side is 3, and the hypotenuse is 7. It says 3 over 7. This side I can get using Pythagoras. Let's just call it A for a minute. And we know good old Pythagoras said A squared plus B squared is C squared. So A squared plus 9, right? There's the other leg, is equal to 49. So A squared is 40. So A is the square root of 40. Okay? Square root of 40, or if you want, 2 square roots of 10. So that's what this missing side of the right triangle is 2 square roots of 10. That should look suspicious again, you know, go back to the triangle over there in the unit circle. And this one is 2 square roots of 10 divided by 7. This one is 2 square roots of 10 by itself. So this blue triangle is effectively 7 times bigger than this one. This one had a radius of 7. This one has a radius of 1. This one has a hypotenuse of 7, 7 times as big. So this is 7 times as big. Instead of 3/7, it's 3, and this one's 7 times as big. Instead of 2 square roots of 10 over 7, it's just 2 square roots of 10. Okay, well, that's sort of interesting. What was I asked to do? I was asked to find the cosine of this angle. Well, look at the picture. Here's the angle. Think about cosine. Cosine is simply, let's see, the cosine of an angle was the adjacent side over the hypotenuse. So the answer to this problem, the adjacent side, 2 square roots of 10, hypotenuse, 7. Done. That seemed way longer than it needed to be. Let me do another example and make it a little bit quicker. Okay, so what is the cotangent of the sine inverse of 5/12? So that's the task. Okay. Find the cotangent of the sine inverse of 5/12. And I've chosen 5 and 12. I don't want 5/12. I want 5/13. I've chosen 5 and 13 because this will be our Pythagorean triple. Okay, so I need the cotangent of an arc or an angle. You can think angle. I'm going to write arc sine of 5/13. I'm going to draw a little triangle. The angle, the arc, the angle, I'm going to call that guy right there theta. I know the sine of this angle is 5/13. Pythagoras says the missing side is 12. Right, there's my right angle. And the cotangent of that angle, let's see, the tangent of the angle was opposite over adjacent. So that would have been 5 over 12. So the cotangent would be adjacent over opposite, which would be 12 over 5. Done. Okay, not too bad. As long as everything's positive, we're in the first quadrant, no negatives to worry about. Okay. What is the sine of the arc that has a sine of -1/3? Now, -1/3 is not one of the numbers I recognize, and yet we need the sine of this arc. So, I told a story to my class about my dog, Nikki. Nikki is the name of my dog. I don't want to draw a picture of Nikki. She had long floppy ears. There's Nikki. Nikki is the name of my dog. So here's the question. What is the name of the dog named Nikki. And you go, well, duh, Mr. Bosque, that's Nikki. What is the sign of an arc that has a sign of negative 1/3? Negative 1/3. Right. What is the tangent of the tan inverse of 1,000,000? What is the tangent of an arc, or angle if you want, you can think of that, whose tangent equals 1,000,000? Silly questions. If I threw that up on my calculator, what is the tangent of the arc tangent of 1,000,000? 1, 2, 3, 1, 2, 3. Mr. Machine, tell me what it is. Oh, it's 1,000,000. Okay, so not too hard. How about this one? What is the arc cosine of the cosine of negative pi over 6? What is the angle? What is the angle or the arc that has a cosine of this number? Okay, so let's figure out what that number is. Because it's in parentheses, we can actually work this out. Cosine of negative pi over 6, that's a nice unit circle problem from last chapter, first part of chapter 6. Negative pi over 6 is right here. There's my dot. It's halfway down. I know this is minus 1/2. This is the square root of 3 over 2. Okay, so the cosine of that angle, negative pi over 6, is square root of 3 over 2. And so now our problem is, what is the arc that has a cosine of square root of 3 over 2? Okay. What is the arc that has a cosine of square root of 3 over 2? That's the question, because this part was square root of 3 over 2. And the answer is not negative pi over 6. So sad. Why not? Well, remember we said the arc cosine is always going to return values on the top of the circle. You've got to be between 0 and pi. You cannot be down here at pi over 6 negative. That's outside of the defined range for cosine. Well, is there an arc or an angle that has the same x-coordinate, square root of 3 over 2? Now, I won't care about the y-coordinate. It happens to be minus 1/2. But you should be pretty obvious that if I go up this way, there's another point up here, which is the square root of 3 over 2. And the y-coordinate now is positive 1/2. And what's this arc? The answer is pi over 6. Oh, I see, Mr. Bosque. You just throw away the negative sign. No, you don't. It's not that simple. There was a homework problem, which was rather strange. I believe it had an arc sine. Arc sine of the sine of 9 pi over 8. I believe this was the one that was assigned. If not, it's very similar to that. Okay, so let's work inside the parentheses first. 9 pi over 8. Well, this is positive angle, so we're rotating this way. If I go all the way to there, that's 8 pi over 8, right? That's 1/2 rotation, 1 pi. But this is 9 pi over 8, so I got to go a little bit further. So that gets me to that. This rotation all the way to there is 9 pi over 8. And there's some number over here. I don't know. I don't recognize pi over 8 as one of my standard angles, but there's some number over here. Could you say anything about this ordered pair? Well, let's see. We're in the fourth quadrant. Sorry, we're in the third quadrant, right? Quadrant 3. So both of these have got to be negatives. So let me just call it negative A and negative B, just to put some symbols there. And the sine of this 9 pi over 8 is a negative b. Arc sine of negative b. How am I going to get there? Well, the arc sine only returns values on the right side of the circle here, right? I have to be on the right side. Remember, arc sine was from negative pi over 2 at the low end and positive pi over 2 on the high end. And this 9 pi over 8 is way too big. So is there another arc that has the same y value? No, yeah, I see it. It's over here. This one going this way has exactly the same y value. So the y value is going to be negative b. Anybody want to take a shot what the x value is? By symmetry, you might guess, and you probably would guess, if this one is going negative a over, then this one's going to go positive a this way. Okay, so what is the measure of that red arc? Well, I suppose you could do it a couple of ways. If we backed up and went over here, so we looked at this pi right here, the blue one was 9 pi over 8. This green one would have to be 1 pi over 8. And the red one would have to be negative pi over 8. And that's the answer to that question, negative pi over 8. As soon as I see arc sine, I know I have to be on the right side of the circle. I do know that this is going to be a negative number, so I have to be down here in quadrant 4. Right? And that gets me to negative pi over 8. Okay, what you should do is go through all the homework problems that were assigned last night. Think about what we did in class today, and then re-look at the solutions and ask questions tomorrow in class if you still don't understand it. Tomorrow's quiz will be on last night's homework, on the Tuesday night homework stuff. So I'll give you some homework problems. And I may give you one or two just plain old unit circle problems, like what is the cosine of pi over 4? You know, just a simple cosine of pi over 4, back from chapter 6. And you should be able to write down very quickly square root of 2 over 2. Okay, let me stop this video here. I hope you have fun working the problems.